Welcome to today's deep dive. We are really glad to have you here at the table with us.
Yeah, absolutely. It's great to be here.
Because if you follow contemporary physics, you are well aware of this lingering frustration with the standard model.
Oh, definitely.
It's undeniably successful, right? But it's propped up by dozens of free parameters.
Yeah, all those arbitrary constants.
Exactly, like the mass of the electron or the fine structure constant. We have to measure them empirically because the theory itself just cannot predict them.
Right. It just accepts them as given.
But today we're examining a framework that attempts to eliminate that problem entirely. We are looking at two really fascinating 2026 papers by Evert van Brummelen.
Yes.
The first one is Equivalence Between Integers and Network Structure, and the second is The Mass of the Electron.
Both incredibly dense, but really rewarding.
Very. And the mission here today is to evaluate this new paradigm. Imagine if reality isn't made of messy, arbitrary physical constants. What if standard SI units, kilograms, meters, seconds, what if we just discarded them?
Which sounds radical at first.
It does. But Van Brummelen proposes a reality built strictly on combinatorial architecture. A giant, elegantly coded network built entirely on single counting and 3D holograms.
It is a rigorous structural approach to a problem that has honestly stalled theoretical physics for decades now.
Oh.
I mean, the reliance on the International System of Units, the SI units, has always been a human construct.
Wait, we use kilograms because it's convenient for us.
Exactly. The universe does not operate on an arbitrary platinum-iridium cylinder kept in a vault in Paris.
No, it definitely doesn't.
So what Van Brummelen is doing is stripping away these anthropogenic dimensions entirely. He argues that numbers are not merely abstract concepts we just overlay onto reality to measure it.
Right.
The integer itself is the physical architecture. It's a fundamental pivot. We're moving from treating math as a descriptive language to treating it as the literal substrate of existence.
Okay, let's unpack this. Starting with the foundational premise in that first paper, equivalence between integers and network structure.
Yes, the network paper.
Van Brummelen argues that an integer, let's call it n, is intrinsically equivalent to a fully connected network containing n nodes.
Right.
And he is quite strict about this. There's no external geometry, no hidden variables, no underlying dynamics required. The integer literally is the network.
It's just pure structure.
Exactly. And to prove this, he relies on a classic arithmetic progression. So if you sum k from k equals 1 to n, that equals n times n plus 1, all divided by 2.
Yeah, the standard triangular number formula.
Right. But instead of viewing this as just a simple arithmetic series, he recontextualizes it. He views it as the absolute maximum number of internal relations within a closed n-body system.
Exactly. And anyone familiar with basic graph theory knows that the formula for the number of edges in a complete graph of n vertices is n times n minus 1 over 2. But Van Brummelen modifies this slightly. He includes self-loops.
Ah, right, the self-loops.
Yeah, which shifts the formula to n times n plus 1 over 2. So if we conceptualize this logically, so you can visualize it at home, you introduce node 1 into a system.
Yeah.
Its only possible relation is a topological loop back to itself.
One connection.
Right. Then introduce node 2, and it requires its own self-loop, plus a directed connection downstream to node 1. That's 2 connections.
So node 3 connects to itself, then node 2 and node 1. That's 3 connections.
Exactly. And by the time you scale up to node n, it has to account for its own self-relation and the connections to all n minus 1 preceding nodes in the sequence.
It's brilliantly simple.
The summation of those connections mathematically mirrors the intrinsic value of the integer itself.
I think the friction point for many physicists reading this, though, is the semantic jump.
Oh, for sure.
Because it's one thing to say an integer is isomorphic to a network structure. It's another to claim an absolute literal equivalence.
Right, that they are the exact same thing.
But this is where he forces us to reconsider what a number actually is. We are so conditioned to treat an integer as a solitary, isolated value, just the scalar quantity.
Yes.
But Van Brummelen is arguing that the integer 5 cannot exist in a vacuum. The very concept of 5 necessitates the structural presence of 1, 2, 3, and 4.
It encodes a relational hierarchy.
Exactly. So an integer n isn't just a point on a number line. It's a rigid framework of n nodes possessing exactly n times n plus 1 divided by 2 connections.
What's fascinating here is the philosophical weight of that exact point. Because if an integer is a network, then counting is not just an abstract cognitive exercise.
Right.
It is an act of literal network generation, and this directly addresses the historical struggle to reconcile general relativity with quantum mechanics.
Oh, the holy grail of physics.
Exactly. We know that treating space-time as a smooth, continuous manifold that works perfectly at macroscopic scales.
Like with planets and galaxies.
Right. But it completely falls apart into infinite probabilities at the quantum level, which is why theories involving discrete, quantized space-time have gained so much traction lately.
Van Bremlin is basically providing a purely mathematical justification for a discrete universe here.
Built entirely on the relational logic of integers.
So before we move on, what stands out to you? Think about how we take numbers completely for granted every day.
We really do.
But what if they are the literal building blocks of the universe? Which is an excellent framework to keep in mind, because this abstract topology is exactly what he weaponizes in the second paper.
Yes, the mass of the electron.
Right. To solve a very tangible, real-world physics problem. As we mentioned at the top of the show, the electron's mass m sub e is an empirical constant in standard physics.
We just accept it.
We smash particles together, we measure the results, and we plug that value, which is roughly 9.11 times 10 to the negative 31 kilograms, straight into our models.
Yeah.
But there is no foundational mechanism dictating why the universe settled on that exact mass.
It's just derived from empirical measurement.
Exactly. But Van Bremlin proposes an equation entirely free of SI units that derives the mass of the electron with a staggering accuracy of roughly 0.9999949 compared to the empirical Kodada values.
That level of precision from a purely derived equation is highly anomalous in theoretical physics. It's just unheard of.
It's amazing. So he proposes a central equation that defines the mass of the electron as equivalent to 3 multiplying components.
Right, let's break those down.
The first component establishes the base unit of the universe's network. The second acts as a dimensional scaling factor, and the third is a structural correction factor derived from nuclear physics.
Let's look at that first piece of the equation. It's E squared over 2 epsilon 0.
Okay.
Now, anyone who has studied electromagnetism recognizes those terms instantly. It's the square of the elementary charge divided by 2 times the vacuum permittivity.
Right.
But Van Bremlin isn't using them to describe a standard electromagnetic field here. He's using them to define the charge capacity of the absolute highest node in this universal integer network.
The highest node.
Yes, which he designates as the U network, the universe network. So the properties of electromagnetism and the permittivity of the vacuum itself act as the defining parameters for the baseline combinatorial node.
And tying those specific constants to a primitive network structure that actually echoes a long-standing intuition in physics, right?
It really does. In fact, in the sources, Van Bremlin explicitly references Roger Penrose's 1971 work on spin networks to ground this.
Oh, nice.
Penrose stated, and I quote, "The idea is that the space-time of physics is to be derived from a more primitive combinatorial structure. The rules of this structure should be expressed in terms of integers and simple counting."
That is perfectly aligned.
Right. Penrose recognized over 50 years ago that continuous geometries were ultimately incompatible with quantum mechanics.
So Van Bremlin is essentially formalizing Penrose's intuition.
Exactly. He is taking the constants that govern charge and space and mapping them onto this combinatorial structure to define the primary node.
Okay, here's where it gets really interesting. Because establishing that baseline node is only the first step.
Right.
If the universe is built on this combinatorial integer network, then fundamentally the universe is two-dimensional.
Yes, a network is flat.
A graph of nodes and edges possesses no intrinsic depth. It's pure relational data, effectively a 2D surface. Yet we obviously operate in a 3-dimensional universe.
We do.
And the electron is a physical entity with a presence in 3D space. So Van Bremlin bridges this gap with the second term in his equation, which is alpha to the power of 3/2.
This, the fine structure constant.
Alpha being, of course, the fine structure constant.
Alpha is arguably the most famous dimensionless constant in physics. It sits right around 1 over 137.
Yep.
And it characterizes the strength of the electromagnetic interaction between elementary charged particles. But the really critical part of this term is the exponent.
The 3/2.
Yes. In dimensional analysis, raising a value to the power of 3/2 is the mathematical signature of mapping a 2-dimensional surface to a 3-dimensional volume.
You're projecting it.
Exactly. You are taking an area x squared and scaling it into a volume x cubed. The ratio of that geometric projection is exactly 3/2.
So Van Brummelen is utilizing the fine structure constant to execute a 3D holographic projection.
Yes.
He's taking the 2D relational data of the initial network and projecting it into a 3D physical manifestation.
Which aligns perfectly with the holographic principle.
Exactly what Gerard Hooft and Leonard Susskind championed in the 90s.
Right. They argued that the three-dimensional universe we observe is fundamentally just a projection of two-dimensional information encoded on a distant boundary.
And what Van Brummelen does is apply this cosmological principle directly to particle physics.
He's arguing that an electron is literally a localized 3D holographic projection generated by the universal 2D integer network.
Which is mind-blowing. The electron is not a tiny solid sphere of mass.
No, not at all.
Its mass is an emergent property of this 2D to 3D geometric projection.
It is a stunning conceptual leap, but it does introduce a mathematical problem.
Right, the offset.
When you multiply the network base node, the E squared over 2 epsilon 0, by that holographic projection factor of alpha to the 3/2, the resulting value is incredibly close to the empirical mass of the electron. But it is not exact.
Close, but no cigar.
There is a structural offset. The raw theoretical calculation is off by a factor of 1.00809.
And in standard physics, if your beautifully elegant equation misses the empirical data by a factor of 1.008, it usually means your theory is wrong.
Or at least incomplete.
Right. You can't just hand-wave an offset like that when you're trying to fundamentally redefine particle mass.
Oh, you can't.
But Van Brummelen doesn't hand-wave it. He introduces the third component of the equation, the network correction factor, which he denotes as FO16.
And the logic behind where he sources this correction factor is just incredibly elegant.
It really is. It hinges entirely on the structural discrepancy between a single hydrogen atom and an oxygen-16 atom.
To understand this, we have to look at the formula for this fix. The correction factor, FO16, is calculated by taking the atomic mass value of hydrogen mu sub H and dividing it by the normalized atomic mass value of oxygen-16, which is mu sub O16 divided by 16.
Right.
When you run this ratio, the result is approximately 1.000814.
Which is almost exactly our missing offset.
Yes, this ratio perfectly neutralizes that structural offset we just mentioned. It pulls the equation's overall accuracy to within that 0.9999949 margin of error compared to the observed electron mass.
But the obvious question anyone looking at this is going to ask is why oxygen-16?
Right. Why not carbon-12?
Exactly. Carbon-12 is the standard reference for atomic mass. Or why not helium?
Well, it turns out it's not arbitrary at all. It comes down to what oxygen-16 represents within the strict logic of a combinatorial integer network.
Binary perfection.
Precisely. If we are operating in a universe designed by discrete structural math, binary configurations are the most stable and harmonic.
Makes sense.
Oxygen-16 contains exactly 16 nucleons, which is 2 to the power of 4. It consists of 8 protons and 8 neutrons, which is 2 to the power of 3.
It's pure binary symmetry.
In the context of the universal network, oxygen-16 blends seamlessly into the combinatorial architecture. It does not disrupt the topology. It is the optimal, most mathematically symmetrical configuration available in nuclear physics.
It's an incredibly elegant workaround because by defining hydrogen not as a base building block, but as a structural friction point against oxygen-16's binary symmetry, he completely bypasses the need for arbitrary mass constants.
Exactly. Hydrogen, with its single proton, lacks that perfectly balanced binary symmetry.
Right.
Within this network model, a solitary hydrogen atom acts as a structural disturbance. It introduces mathematical friction.
And that friction is exactly what generates the offset. The mass of the electron encapsulates this fundamental tension.
It isn't just a random value.
No. Its exact magnitude is partially defined by the structural gap between the universe's most mathematically perfect binary configuration, oxygen-16, and its most basic asymmetrical disturbance, hydrogen.
The mass itself is literally a record of network geometry.
Which completely reorients how we view the standard model.
Completely.
But before we wrap up the analysis of the electron mass, we really need to shift our focus to the footnotes of the second paper. Because when Brummelen expands the scope of this math far beyond just a single particle.
Yes, the macroscopic implications.
He outlines the potential of the U-network, the universal network. If we treat n as the total radius of this universal integer network, Van Brummelen shows that you can derive the foundational properties of the entire cosmos using basic polynomial expressions.
The scaling is remarkable. He demonstrates that if n's the radius of the universal network, then the expression 1/2 n squared corresponds directly to the total mass of the universe.
Wow.
Furthermore, taking that progression a step further, the expression 1/2 n cubed calculates the total number of baryons in the universe.
Baryons being the class of subatomic particles like protons and neutrons that make up all the observable normal matter around us.
Exactly.
So we're moving from calculating the sum of simple integers in the first paper to deriving the exact number of protons and neutrons in the observable cosmos using a simple n-cubed function.
It's a level of mathematical determinism that almost feels uncomfortably precise.
If we connect this to the bigger picture, why does this matter so much?
The profound implication is the total removal of randomness from physical law.
Yeah.
For generations, physicists have operated under the assumption that the values governing reality are empirical accidents.
Right. The speed of light, the mass of the top quark, the fine structure, constant.
We measure them, but we cannot deduce them from first principles. Van Brummelen's framework suggests that this assumption is flawed.
The experimental data is still valid, though.
Oh, definitely. The hard-won data of experimental physics, the measurements from CERN and Fermilab, they remain perfectly valid. The empirical observations are not wrong.
But the theoretical scaffolding we built around them is.
Yes, because it's so heavily reliant on arbitrary SI dimensions, and that obscures a deeper truth. In a purely combinatorial reality, there are no independent floating constants. Every physical value is structurally interlocked by the rigid hierarchical relationships of integers.
So what does this all mean? For you listening right now, balancing these equations against everything you know about standard physics.
It offers a radical new lens through which to view reality.
Exactly. We are asked to entertain a universe where standard dimensions are just an illusion. The next time you look at a simple number or consider the mass of an object around you, you aren't just thinking about a localized clump of matter interacting with the Higgs field.
No.
You're considering a three-dimensional holographic projection governed by the fine structure constant emanating from a perfectly connected two-dimensional integer network spanning the universe.
It suggests that the underlying code of reality isn't a complex, chaotic mess of disparate forces.
Right. It's a perfectly rigid structure derived from the simple act of sequential counting.
It really forces us to synthesize our understanding of complexity. We often view advanced particle physics and basic arithmetic as occupying two entirely different conceptual domains.
We do.
But this framework insists that they are identical. The relational topology of simply counting from 1 to n contains the requisite mathematical DNA to construct physical mass, define vacuum permittivity, and dictate the total baryonic density of the universe.
We have covered substantial ground today. We started by unpacking the claim that an integer is not a scalar quantity, but a fully connected network of nodes defined by the arithmetic progression of maximum internal relations.
A massive conceptual shift.
Then we applied that topological logic to the electron, dissecting an equation that derives its mass completely without SI units.
Relying instead on a baseline charge capacity node, a 2D to 3D holographic projection scaled by the fine structure constant.
And a structural correction factor rooted in the binary perfection of oxygen-16 versus the asymmetry of hydrogen. It is a dense, paradigm-challenging framework, and we are thrilled you took the time to explore it with us today.
This raises an important question, though, and it is the logical extreme of Van Brummelen's topology that I really want to leave on the table for consideration.
Okay, let's hear it.
We established in the first segment that an integer is never isolated, that the number n physically requires and encodes the exact structural history of n-1, n-2, all the way down to 1.
Right.
If the universe fundamentally operates as a single expanding integer network, then every new node inherently contains the entire combinatorial architecture of the past.
Oh, wow.
So does that imply that the historical progression of the universe isn't just a sequence of events that occurred and vanished, but is permanently and mathematically encoded into the current topology of the very particles making up your own physical reality today?
That is a staggering implication to end on. A universe where the past is not gone, but structurally archived right there in the geometry of every present atom in your body.
It changes how you look at everything.
It really does. Thank you again for joining us for this deep dive. Keep scrutinizing the models, keep questioning the consensus, and keep exploring the mechanics of the universe around you. We will see you next time.